Okay, so another situation in which samples and populations are used would be things that involve large amounts of nature or space or woods or forest or ponds. So, for example, if you wanted to learn about the types of fish that are in a pond, you wouldn't be able just to drain the pond and decide and start counting all the fish. They're going to be dead. So you would grab samples of fish, and then you'd be able to say, oh, well, we got 3 bluegill, and we got 4 largemouth bass, and we got 6 catfish, and we have 7 crappie or whatever it is that come out of the pond, and you can use some of that data then to make by doing it in sections a little bit more in space, you can kind of get some numbers about the pond, and you can kind of figure out, well, we have twice as much bluegill as we do crappie and that kind of stuff. Same thing goes for things in the woods or in the forest or in a conservation area. So on a question like this is pretty similar. So to determine the number of rams in a conservation area, they call it a catch and release program. So let's say you want to learn about like all the deer, well, and how much deer are in a certain amount of woods. You would catch a certain amount of deer and they tag the deer. They put like little clips in their ears. Sometimes they do that with ram or different types of wildlife. So in this case, they're going to catch and mark. They call it a catch and release. You're going to mark the ram. So they grab 103 ram. A researcher catches and marks 103 different rams. Okay. And then this researcher releases them back into the woods. So they go back into their conservation area and they're all running around and they all get mixed in. They're eating and they're hanging out with all the other, ones that haven't been tagged. And then they wait a little while and some time goes by. And then later on they catch, they catch a certain amount. What they catch is their sample. So now they're going to go pull out a sample after some have been tagged and lots of them haven't been. So they're going to pull out a sample of 89 and they grab those 89 and then they look at the 89. That's their sample. And in this case, 21 of the 89 that they pulled out were tagged. So what that means for us is that 21 were tagged in the sample. So 21 out of the 89 were actually tagged. So remember, this number in the bottom, this is the whole sample group, okay? This is how many were actually tagged, okay, in that sample that came out. But what we're trying to find here is we're trying to find out, well, I wonder what the entire population is. So we want to know not the numerator up here, we want to know the denominator. What I do know is that, remember in the beginning, we tagged 103. So 103 of the entire group had tags. I'm putting my 103 in the numerator because that's where the tagged numbers went. So this is the 21 were tagged out of 89. Well, I wonder 103 were tagged out of how many? I can go solve for this X value right here, okay? And to solve for this X value, I could cross multiply and do 89 times 103, and I can set that equal to 21x. So I can do 21x equals whatever 89 times 103 is, and then I can solve for x. Sometimes we can find out, well, 21 times what gets me to 103? Well, then 89 times that same value gets me to x. And so we know right now it's going to be about 5 times bigger. Like I can just ballpark this right now. This is almost 5 times bigger here. Well, then this is about 5 times bigger to get to here. So I should be expecting my answer to be right around 450 or so. And so I'm going to let you finish this question off. You'll see this question again a little bit later on during one of your quick checks or your quiz here at the end. Okay. But that's exactly how this is used in the real life. This is how they do this in conservation areas. This is how they do this with grabbing a sample of a population and determining how much is that population or certain characteristics of a population. Okay. Email me if you have any questions or see me at the 1:30 check-in time. Thanks.